All right, class, welcome to 4.5. We are going to go backwards on our graphs. So what we want to do is we want to find the equation based upon the graph. So far, I gave an equation and you had to graph it. So let's go with going backwards. All right, let's jam, and then we're going to also do 4.6, but we'll do it with a calculator. So let's go with it. So if you have your notes out, please do so. Write down 4.5, finding the equation from a graph. All right, and if it's from a graph, I guess I better give you a graph here. So exercise 1, here's my graph. If you want to copy it down, go for it. Let's do a very, very easy one, and then we'll get into the equations for them. Very easy. So 2 pi, if that's the case, that's pi. And if that's the case, that's pi over 2. So remember, I like to do this here. This is 1 pi over 2. This would be 2 pi over 2. This would have to be then 3 pi over 2. And 4 pi over 2 would make 2 pi, so that's perfect. So I get to check it at the end. And let's go with 2 notches up, 2 notches down. That'd be good enough. So this represents negative 2, that represents positive 2, and I have a function that does this. It starts off at 2, goes down to 0, goes all the way down to negative 2, turns back around, goes to 0, and goes to 2. And the curve kind of looks like this. Voila. So my question to you is, do you know this graph? So the more familiar you have with the graphs themselves, the more you've seen them. So you think to yourself, is this a sine curve or a cosine curve? That's a cosine curve, that's right. It's not moved in any direction, right? It starts off high, right? Goes down low, and then goes up high. Okay, so really this is just a cosine curve. And cosine curve has a period of 2 pi, which it does here. The only thing that's different is the fact that it goes up to 2 instead of to 1, and it goes down to negative 2 instead of negative 1. So there's just, your amplitude has changed. So tell me if you guys agree here. So y is equal to, this is just 2 cosine of x. That's it. Nothing else. So of course, that's the easy one. All right, now let's get into a little bit more complicated stuff. Let's go with it. So this amplitude piece is pretty easy to get. Let's go exercise 2. Here's my graph, and if you can stay ahead of me, go for it. Please do. All right, I'm going to go all the way up to pi. Half of that would be pi over 2. Half of that would be pi over 4. So this is pi over 4. 2 pi over 4, this would have to be 3 pi over 4. And then this would be 4 pi over 4, which makes sense. Cool, cool. I'm going to go 3 down, and I'm going to go 3 up. And just waiting for you guys to catch up a little bit. All right, and this graph is going to go start very, very low, goes through 0, hits a high point, goes down to 0 again, and then back down to a negative 3. The graph connects like this, and then comes up. Little roller coaster, that's all. All right, what does this look like? Cosine or sine? It looks like cosine to me, is that right? Except it's inverted, right? Instead of high, it's starting low now. Okay. So let's see. Here's what I'm going to do. I'm going to put down the basic and generic formula for it. We'll do sine in just a second here. Well, let's do this here. So it's going to be A cosine. I think you've seen this before. Capital B. x minus h, bracket plus k. So all we really need to figure out is a, b, h, and k. Figure those out, we are in good shape. So first things first, the a value. So the amplitude is 3, right? Because it goes up 3, goes bottom 3, and it starts low. So you know it's a -3 for amplitude for a value. Now we need to figure out is the b value. You guys remember the formula for it was b, or the period was equal to 2 over b. Oh, sorry, 2 pi over b. All we're going to do is we're going to switch them. We're going to move the b over here. We'll put the period down there, and we have solved for b. So 2 pi divided by, what's the period here? Starts off at 0. By the time it goes all the way up, by the time it goes all the way down, it took a pi value. Oh, that's cool. Just put pi there. Pi's cancel. B is equal to 2. Plug it right back in. There it is. B gets a 2 value. Now H. H, is this graph shifted in any way? No. Remember with cosine? Cosine hits the top or bottom right when it begins at 0. So no shifting. So just be x, I don't know, -0, I guess we can do. Did it go up or down? Or is the middle right at 0? Oh, right at 0. Okay, so got that. Okay, so then let's go for it. Yeah, the only thing we got to do is just simplify all the stuff out. So -3 cosine of just 2x. There it is, all done. Perfecto. All right, so a question usually comes up is, Mr. NG, how do I know that this is a cosine curve and not a sine curve? And the answer is, it doesn't matter. It doesn't matter just because we just want an equation of this line. I can use it, and I can make it to be a cosine curve. I can also make it to be a sine curve. Let's check it out. So, dun, dun, dun. Next slide, if you want to write these down, these equations, here's your 2 equations. For sine, we just need to figure out the a value. We need to figure out the b value, the h, and the k. For cosine, we need to figure out the a value, the b value, h, and k. So you know what? Let's do this here. Let's return back to our graph in exercise 2. Let's go back to it here. So if you want to rewrite it, that's fine. I'll put exercise 2 right over here. I'm going to graph it again just real quick here. It goes out to pi, half of that, pi over 2, half of that, pi over 4. And then that means 2 over would make 3 pi over 4. I feel like I've graphed this before. Oh yeah, I have. True, true, true. Okay, there it is. -3 goes up even higher, comes back down totally. Okay. So question is this, what happens if I want to make this into a sine equation? I kind of have 2 options. So let's go with this one here. Oh, you know what I did? If you want to rewrite this, I put like a little star or something like that. I put EX with a little star next to it like this. Just to remind me, I'm doing the exact same problem a different way. That's all that means. Exact same problem, a different way. All right, so let's jam with it here. So if we wanted to, we can just extend this out. So kind of careful here. Look at this. I'm going to extend this out backwards. So if this one went backwards, it would have went all the way up to here. It would have been a pi over 4. I'm going backwards on this little section here. It would have been like this. Does that look like a sine curve? Yeah, it does. Remember, sine curve starts in the middle, right? It either goes up or down. In this case, it goes down, then up, and then back down. So sine curve goes like this. There it is. Started in the middle, went down, went back up, and came back to the middle. Oh, you know what? I also could start, so there's a starting point. I also could start the sine curve over here. I could start it just normally. I could start it like right there. Isn't that beginning of a sine curve? Yeah, sine curve that goes up and down. Now, it doesn't extend out all the way, and that's okay for me. It doesn't come back to the middle. That's okay by me. I just know that eventually, if it did come back right over here, it would be at I don't know, 5 pi over 4, I guess. Is that right? And again, I don't even need to know that because from a period, I can judge the period whenever. I just need it to start repeating itself. All right. So let's go with it here. So here's my generic sine function. And we do whatever is easier. That's what we do over here. We do whatever is going to make the most amount of sense. So what I'm going to do is I'm going to start my sine function. I'm going to think of this as my starting point right here. If that is my starting point, let's see. How far does it go up and how far does it go down? 3, is that right? And this is because I'm starting it and sine goes up initially, it's a positive 3. What is my formula for my period? And this one again, I don't have to start here for my period. I just need to know when does it start repeating itself. So it starts at 0, starts repeating itself at pi, so it's pi. And now the fun begins here. So x, so now the question is, since this is a sine function, I need it to start here. So it's going to be a minus pi over 4. Remember, the h is a starting point of our function. Has it moved up and down? No, it has not. That's 0. So there it is, 3 sine of, and I got to multiply this out real quick here. So 2 times x, 2 times a negative pi over 4 makes pi over 2. There it is. There's my sine equation, or sine equation to this graph. And I also had a cosine equation to the graph. It doesn't matter. Both are true. What we normally like to do is, if you don't need to do a phase shift, don't do a phase shift. Just stay with what you have. If you have to do a phase shift, that's kind of like the next step in the process. Okay, I'm going to let you guys do the next one by yourself. Please try this yourself. All right, I'll give you guys a little bit of time. So exercise 3. Here's my function. Divide them into 4 pieces. Boom, 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 boom. And this graph goes up, up, down, down, up, up, down, down. All right. Give you people's 2 minutes or a minute and a half. Try this yourself. I have my timer on. If you are done, then check with the person next to you. Okay, maybe a minute. Minute at least, try to see where you're at. Is the people who have got it, and the people who are still waiting, I'm going to wait just a little bit. All right, yes, the question in my mind that comes up is, which function is this? Does it look more like a cosine curve or a sine curve? Yeah, cosine, definitely want to do. Again, cosine. Oh yeah, that's right, the notches are -3 and 3. And so, cosine it is. All right, and got about 10 more seconds here. And let's go with it here. So it is an upside down cosine curve, is that right? It goes upside down. So I'm going to start off with -3. It's cosine. My b value is 2 pi over my period. So how long did it take for me to go from the bottom, go up, and go back down to the bottom? Pi over 2, right there. Oh, this one, remember this one here? The complex fraction, so it's going to be 2 pi over 1 multiplied by the reciprocal of this guy. So as I move it around, 2 goes to the top, pi goes to the bottom, pi's are gone. So left with 4, and if you got 4 for B, doing great. And I think I have everything I need because I haven't shifted sideways. I have not shifted up. So H is 0, K is 0, and we're on our way. So I'm running out of room over here, so let me rewrite it up on top of the next slide. So I have y equals -3 cosine brackets. I got a 4, and in parentheses I got an x minus 0. Close the bracket, and it's still a 0 because there's no vertical shifting, or as I say, vertical translation. All right, simplifying this out as you have to. -3 cosine of 4x would be the simplified version of that equation. All right, so let's get a little tiny bit more complicated. Of course, that's the fun part. All right, here it is. Give you maybe a 30-second head start as I graph this. So here's what I got. I go all the way out to 20. Now, just some notches here. This is going to be 10. That's going to be 110. That's fun. The bottom value is 10. The top value is 110. Back to 10. Back to 110. Back to 10. And the graph goes like this. And that is all I need to give you. All right, 30 seconds. Head start. Go for it. Let's see if you can figure out, maybe figure out the middle. What would like to be the middle of that thing? All right, so now question is, man, I see the bottom, I see the top, but I need to figure out what the middle is. So yes, of course, there's a little equation for it. The middle, how do you find the middle? All you do is you take the x, the maximum value you have, you also add it with the minimum value, divide by 2. And that should give you the exact middle of 110 and 10. Technically, you're just getting the average between the two numbers. So maximum is 110, minimum is 10, divide by 2. I have 120 divided by 2, or 60. So now I know 60 is my middle. Now remember what my A value says. A value is the space I need to get from the middle to the top or the middle to the bottom. So how much is it going from 60 to get to 110, or from 10 to get to 60? So that's 50 each. That's perfect. Okay, I think I have everything I need now. Oh no, the phase shift, no phase shift. The period, that's what I'm still looking for. That's right. Okay, we'll find the period in just a bit here. But let's write what we know. Does that look like a right side up cosine curve or an upside down cosine curve? Looks like upside down to me. So the 50 here that we go up and down, 50 is the up and down version, right? That's the amplitude. Cosine, so I guess I'll do the formula first here. So A would be the 50 if we want to put it down. B, and there it is. Again, just rewriting the formula just to make sure I have it. And I figure once I rewrite it about 10 times, I will memorize it. All right, so all the stuff that we know, the A value is where we go from the middle to go to the maximum point, or from the middle to the minimum point. In this case, it's 50. That's cool. So let's put in the 50 that we know, and it's an upside down cosine curve. So it's going to be, I'm missing my 50 here. I'm going to write in my 50. I got a little bit too ahead of myself here. and the b value. B value is going to be 2 pi. Notice on the graph itself, it goes out to 20, right? But notice it actually does 2 different cycles, right? It goes from the bottom, goes up to the bottom, and then again from the bottom to go up to the bottom. So we only need to capture one of those, and that's a period. So from 0 to 10, everything is different. And then from 10 to 20, it starts repeating itself. So our period is only from 10. And I reduce it, becomes pi over 5. And that is my b value. Have I shifted anything over? Nope. So that's going to be minus 0. Have I went up? Oh, yes, I have went up. So the middle of my graph now, instead of as at 0, it now is at 60. Okay, let's see if I wrote there. So final answer, negative. Let's see, forgetting my 50s here. Negative 50 cosine of, I'm going to just multiply the 5 pi over 5 times x plus 60 and done. Oh, there's my 50, there's my 50. Okay. See, I did remember my 50s. Okay, so we worked with amplitude pretty well. We worked with the k value pretty well. Let's work with our maybe the phase shift value. Here it is. Let's go with that. So exercise 5. Here's my graph. All right, I know it starts off at negative pi over 6, ends at pi over 2, and it just goes up and down. That's it. Wow, I'm not sure if I'm hitting my middle right here or not. I don't know. I could be not. I have no clue. All right, 30-second head start, go. Put in everything that you know. Again, what does it look like? Initially, what does it look like? It looks like a cosine curve, upside down cosine curve again. Oh, that's right. I need to tell you how much it goes up. That's right. Sorry about that. It goes up to 4. So let me write this in. So cosine, what I would use. Next is I need my middle again. Middle of my graph. It's going to be max, which is 4, plus 0, which is down here, over 2. Oh, okay, that's fine. Yeah, of course. So the middle of this graph is 2 right over here. That's the middle of the graph. And I'm not sure whether it hits the middle. Yeah, that's cool. So middle is 2. Then also notice that the middle is actually technically the k value. Ooh, that's kind of cool. All right, now we need to figure this out. We need to figure out the period itself. So how do you even figure out the period if it doesn't look very nice in the graph? So period would be the, and I just say the end or the right side. You can say the right end minus the left end. So the rightmost end is all the way over here. This is where it stops. So this is pi over 2 minus the left end right here where it begins, but then it's a negative pi over 6. So it's going to be here inside of a little parenthesis of negative pi over 6. All right, if that's the case, oh, that's cool. So that becomes plus plus. So I got myself a pi over 2 plus pi over 6. And I need common denominators. Common denominator is going to be a 6. That's cool. So 2 times 3 gives you 6. So 3 pi plus pi makes, oh, 4 pi over 6 or 2 pi over 3. Now that's my period. I need that to tell me my B value. All right, my B value would be 2 pi divided by 2 pi over 3. And again, a complex fraction. So here we go, 2 pi over 1 multiplied by the reciprocal. So switch that around, top and bottom makes 3 go on top, 2 pi's on the bottom, and the 2 pi's are gone. They will cancel themselves out, leaving us with 3 being the B value. Okay, so upside down cosine curve. And it goes up 2 and it goes down 2 from the middle. It goes up to 2, or it goes up 2 and down 2 from the middle. So that's going to be my A value. So y equals -2 because it's an upside down cosine curve. That's the negative comes from. This 2 comes from the fact that the 2 is right in the middle between 0 and 4. So that's the middle value. And that's how much it goes up to. So from 2 to 4, it's a value of 2. And then from 2 to 0, it's a down value of 2. Okay, cosine. We just figured out our B value is 3. Oh, and then do we have a phase shift? Yes, we do. The formula says we have to put a minus sign. But the start of our cosine curve is a negative pi over 6. That's cool. So what we do is we just make these positive here. And then it will be a plus, plus 2. That's how much it went up. That's the middle of our graph. Okay, and we've got to simplify it here. -2 cosine of, multiply the 3 to the x, multiply the 3 to the pi over 6 makes a pi over 2 plus 2. We are done. Dun, 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 dun. Okay, we worked on the phase shift. That's a good thing. All right, and I figured it'd be kind of cool for us to do sort of real life situation kind of thing. So first things first, got to read these guys a little bit here. Cepheid, I think it's a Cepheid. I think that's the way you pronounce it. A Cepheid variable star is a star that pulsates radially and varying in both diameter and temperature. It'll become bright and they'll become dim. And the interesting thing about it, it has actually a stable period and a stable amplitude. All right, they are important pieces in our solar system. And we know they're stars because they pulsate, so therefore they move slower than other planets and planets around them. So we can use their coordinates in space in order to map things out, which is kind of a cool thing. So basically, these are stars. They'll become bright for a certain part of the year, and they will become dimmer for another part of the year. And that's the way they just fluctuate. So then I went and got a graph of one. That was kind of cool. So here's a graph of one. So this is exercise number 6. You can kind of sort of put things in. So this is a Cepheid variable star called a V1. And it is in the galaxy M31. Did you guys know we have a galaxy called M31? It's almost like a little small license plate number, right? Yeah, galaxy M31. All right, so this particular star called V1, here's its brightness. So it looks like they started to map this in like July. So in July, it kind of went up, and I'm not sure if that's the halfway point, because the halfway point would have been like closer to the G, I think, in my mind. So they started mapping it in July, and it goes up and down and up and down. That's the brightness of it. And over here it says it has a period of 31.4 days from the time it's very dim to the dimmest times. That's cool. And then what I did is I put down the illumination factor. So at its dimmest point has a 3.65 illumination factor, and its highest point has a 4.25 as its greatest illumination factor. Then I had to do one more thing. I had to find out when is it dimmest. It looks like it's right in the middle of August. It's exactly in the middle of August right here. So then what I did on my calendar, I went online and I figured out what is the day, what's the calendar day for August 15th. Looks like it hits it right in the middle. So I found out the day 227 is the calendar day. Calendar 227 is August 15th. Okay, all yours, 30 seconds or 45 seconds or so. Can you do as much as you can of this? Oh, that's right. Are we going to convert it into a sine or cosine curve? So here's the thing. It is pretty difficult to figure out where the middle of something is, right? It's like, oh yeah, it's right in the middle of its brightness. It is much easier when we look at stuff to see when something is its very bottom, so at the dimmest point it has, or at the brightest point it has. So that's why we use cosine curves, use a lot for modeling. So I'm going to pick the fact that this is going to be a cosine curve. And it's going to start for us on August 15th or on day 227 of our calendar year. So go for it. 30 seconds, try to make as much sense as you possibly can. And try to get an equation, a cosine equation, for the illumination cycle of Cepheid variable star V1 in the galaxy M31. All right, I'm going to try my hand at it as well. So let's go for it here. So the M, I'm going to put M as the middle. The middle point. So maximum plus minimum divided by 2. If you add this up, you should get a 7.9 divided by 2, so that's going to be 3.95. That's the middle. So 3.95 is the middle, and it goes up to 4.25. Also, it goes down to 3.65. The question is, what's the difference? How far does it go up from the middle? And how much does it go down from the middle? So how far does it go? How much does it go up from the middle? And how much down it goes from the middle? All right, and I'm thinking like, from 3.95, I think I add a 0.3 to get me to 4.25. If you want, you could just subtract these two numbers. Same thing here, from a 3.65 to 3.95. The difference would be 0.3. Perfect. I got it. That's my amplitude. Now the only thing is, that's my amplitude. Since I have an upside down cosine curve, because I'm starting it on August 15th, my A value has to be negative. Since we're going to go starting on the very bottom of a cosine curve. And the B value, I just put M for middle. That's just, that's right. We also could use K, huh? Actually could use K over here. K would be that answer. All right, for the period would be 2 pi divided by, and it said 31.4 days. So anybody on the calculator, write 2 pi divided by 31.4. 0.2, like 0.200148, something like that. So I'm thinking 0.2 would work just fine. I think we're ready. Guys, we're ready to model by an equation the brightness and dimness of a star like many, many miles away in the M31 galaxy. So y equals negative 0.3 cosine 0.2. And then how much of a phase shift do we have in terms of days? 227 days. That's how much we've moved away. And then how much do we have to go up? Yep, we got to go up 3.95 to the middle of our graph. There it is. Normally we just kind of leave it just like that. Okay, perfect there. Okay, that was 4.5. Hopefully it started off easy, became a little more difficult, and then became interesting. All right, let's jump to the next one. 4.6. So 4.6, it's called graphing combinations of functions. Graphing combinations of functions. All right, so first things first is what do we have to graph, Mr. G? Here it is. We're going to graph. We're going to graph from x equals 0 to x is equal to 4 pi. On the homework? Yeah, that's right. Yeah, that's the way it is listed on the homework. Okay, what are we graphing? Graphing a is equal to a y plus 1 plus cosine x. There it is. That's what I'm graphing. All right, remember, oh man, I don't like the way it's written like that. I always like it when the cosine, when the trig function goes first, and then I have that, because that just tells me I am one up, right? Let's do an easy one, just to get us started. All right, so get out your calculators. Let's do that with our calculators here. I'm going to go show toolbar. I'm going to jump to this guy here, and here is my calculator. Sophisticated. All right, so get out your calculators here, turn them on. First things first is notice the mode that you're in. So 0 to 4 pi. So we're going to go to mode. We're just going to check, make sure you are in radian mode. If you're in degree mode and that's highlighted, go to radian, click enter. So the radian mode is highlighted. All right, and let's go with it. All right, lots of work on the calculator here as far as things are concerned. So let's go to y equals right here. Y equals. And we're going to punch in cosine of x. That's the variable right there. Plus 1. Enter. All right, what we're going to do, we're going to go up to our window. Whoa, that's huge windows here. Let's talk about this here. So cosine, remember cosine is only going to work, cosine really just goes up to 1, right, and goes down to -1. That's all it does. All right, and then we also have a domain already given. We want to go from 0 to 4 pi. Okay, so let's go with it. Let's go 0 to 4, and we need to find the pi button. Pi button's right here. It's on top of, it's called the caret button. So second function, pi, enter, good. Okay, now the only thing is I want to divide this up so it makes sense. So I can divide up into like pieces of 10 or, oh, you know what I can do? I can divide up into pieces of 4. If I do this right here, this would make sense, pi. Okay, Now my y minimum. So let's see, this is really just going to go from -1. I'm going to go to 3. So, because I know this, I know that cosine, the most maximum cosine is going to be is 1. If I add one more, the maximum this guy's going to be is 2. The minimum this guy's going to go is -1. If I add 1, it would be 0. But I just need a little bit of space. And I'm going to go with y scale by 1. That's how many tick marks we have. Okay, just keep x raised as 1. I think we're ready for our graph, guys. Let's go with it here. So click the graph button. Let's see it. Boom. Oh, nice. There it is. Yep, start off with 2 because it's a cosine function, right? Went down to 0, went up to 2, went down to 0, went up to 2. There it is. It's a W. Okay, if you got that one, great. If you didn't, help the person next to you. You just kind of check, make sure they're in radian mode. Make sure they put in the y value correctly. And make sure their window is correct right over here. All right, let's go on to the next one. All yours for this one. Try it yourself. All right, let's see if I can, yeah, okay. So it's still going from 0. So let's go back up to here. So we're going to here, we're going to clear this out. We are still in radians, that's good. So x plus cosine of x. Click enter, done. Okay, we're ready for that. All right, let's go to our window and actually let's see, let's graph this. Let's graph this the way we had our new window set previously, like this. Oh, wow. Oh, that's no fun. Look at that. It just got a little piece of our graph. Last time it was right in the middle. Okay, what's happening here is that this x value is affecting it to go higher and higher each time, right? Cosine is still between 1 and -1, right? But this guy's the problem. This guy's going up higher and higher and higher. So this is where I have to play with our windows here. So I'm going to go here. I'm thinking to myself, what does, if it's 4 pi, so let me just find out the value of 4 pi. So 4 times pi is going to be the x coordinate. So notice the x coordinate is stretching out to about 12 and a half, right? So then I'm thinking, well, that means if this is x here, that means this also stretches out to 12 and a half up too. So I'm going to go 15. Let's go 15 on our window. So window, we go from 0. This still has to be 4 pi. No changes there. This is still 4 pi because it told us how to do it in the first place. This is still pi. But our minimum is going to be -1 for my y value. That's going to be 15 for the y value for the maximum. We can still go up by ones. So get that cleared on your window there. And let's click the graph button. Let's see what we get. Let's see if we get a nice graph. Nice. Okay, we good there. So the whole entire graph is in my view. It's almost like if you look diagonally, if you put your head off to the side, it's the cosine curve going up and down. It's going up and down along the x value. That's what it's doing. All right, just practicing, just trying to get our window correct. That's what we're doing. Okay, yours. Try to do this one by yourself. Thing. All right, so let's see, sine of x and then cosine of x. Kind of think about my window. That's what I'm trying to do. Think about my y window. So these are just both trig functions. So hold on. Sine of x, the highest this guy can go is 1. The lowest is -1. Cosine, the highest this guy can go is 1, but then also there's a 1/2 over here. So wait, the highest this thing can go is 1 plus 1/2. So 1.5 is the highest this guy goes. The lowest this guy can go is -1, and the lowest this guy can go is -1/2. So this becomes -1.5 lower. Okay, let's see if this makes sense. Window, still going from 0 to 4 pi by pi. But now my window is going to be negative, I don't know, -2. You can put -3. I put -3 and 3. Because the highest this guy can go is 1.5, the lowest is -1.5. Press graph, let's see what we get. Oh, wow. Oh, sorry. I was on the wrong graph. Haven't put this in here, so there it is. Sine of x plus 1/2. Half is the same thing as 0.5. So I'm going to put 0.5. Cosine this one, I need to 2x. And grab it. Hey, that was a pretty good graph. Look at that. It goes up and then it kind of just goes down for a little bit and then comes up, wobbles a little bit and kind of goes back down. And I'm sure it's going to repeat itself. It'll wobble again, goes back down. But there's our graph for the trig functions here. Okay, if you got those, doing great. All right. And next one, all yours by yourself. Go for it. See if you guys can do this figured out. I give you guys 30 seconds head start here on this one. All right, I'm going to go over here. So I don't forget, I'm going to change my value here. So this is sine of 2x minus 2 sine of 3x. So change my function. Now I'm thinking to myself, okay, that's going to be the highest this guy's going to go is 1. The highest this guy's going to go is negative. Hold on, that's a -2 this time. Hold on. So if this guy goes a -1, this would be a +2. Okay, hold on. So the highest, this guy goes 1. Highest this guy goes 2. Is the highest both of them can go is 3. Okay, that's cool. So see if that makes sense to you guys here. My window, I'm just going to expand this out to a -5 to 5. That should work. Let's see what we get. Oh, nice. Oh, wow. Looks like almost like a sound wave. Vroom. When you change volume on a sound wave. There it is. And hopefully that made sense to you because there's only trig functions here. Remember sine, the highest they'll go is 1, the lowest is -1, so you can judge between the two how this is all going to work out. All right, and boom, boom. The last one that we have, a little bit different, all yours to try it yourself here, but now we're going to go from 0 to 8. Now we have real numbers in front of us. See what we get. All right. Let me grab this guy here. So if I don't grab it from there, oh, can't go there. All right, a little difficulty here. We'll figure it out. So screen, boom. There it is. That's the way I want it. Okay. So, oh, notice this guy is not a trig function. This is just a normal x. Okay, because that's going to go up just like the 8, right? So at 8, it's going to be high as 8. So this one's when we're going to have to sort of reshape the graph here. So my window, I'm going to go from 0 to 8 because that's what it tells me to do. Those little tiny tick marks on my graph, I'm going to use them as 1s. But by the time this x gets to 8, it's already going to be 8. And the highest cosine goes is 1. So the highest this guy would be 8 plus 1 is 9. So I'm going to go 10. 10 on this one. And the lowest this guy can go is 0, right? Because we're starting at 0. Lowest cosine value goes -1. So I'm going to use -1. Kind of will give me a little bit of a space and gap. Okay, oh, let me make sure. I almost messed it up again here. I went over here, and I better clear this and put in the correct function here. This is x plus cosine of pi x. So that means every 2 there's a cycle, right? Because it's going to be 2 pi divided by 2. All right, and let's graph this guy. Oh, air, window range. Oh no, let's go. Something I did wrong. What did I do wrong? What? Mr. Ng have messed up? What? Okay, third mistake ever in my lifetime with mathematics. Y min should be a -1. You put in your minimum value and then you put in your maximum value. I was doing the other way. Minimum value, maximum value. Yep, that's cool. And now let's go with it. To graph it. Oh yeah, that's cool. Makes sense. There it is. There's my graph of it. Looks like a little bit of a hill going up or something like that, right? A little bit of a hill. All right, with that, that was our last problem. If you understood that point, that's cool. If not, come back and after presentation on Monday, I'm going to go over any homework questions on Monday after presentations. You'll have a good weekend and see you Monday.